Okay, let me just make sure I got everybody written down that's here online. Let's get you. Okay, let's talk about how to create. Oh, what's up? I need to turn on my projector a moment. Okay, okay. Slideshow from beginning. How to create a residential footing and foundation. The purpose of a footing and foundation plan is that when they start building the house, in theory, just from that drawing, they could start laying out. Well, they would need a site plan to show where the house goes, but once they know where the house is supposed to go, they could start laying out the footings, building the footings, laying out the foundation walls, building the foundation walls from this one document, which is called the footing and foundation plan. So we're going to talk about how to do that. And it's not super complicated. And I'm going to show you some examples that are computer drawn, and then I'm going to show you some examples that are hand drawn. This is a hand drawn one that I did for my parents. And in this one, and I'm giving you a PDF copy of this just to look at it as an example. I'll tell you what, rather than show you this crappy one, let me just show you that one. I think it's on Blackboard. Give me a second. So if you go to structural concepts and we look under assignments and we look at footings and foundations, in this assignment that we're going to be working on, I give you some examples, hand drafting. I think that's the one. So let's go ahead and download. Yeah, that's that one. Let's go ahead and download that. And I also give you a PDF of a computerized one. Now, in the future, I don't know what I'm going to do because the government's got a new law that everything I post on Blackboard, since it's a government website, has to be readable by blind people. So the computer needs to read everything that's on there. And so if you have a scanned drawing, that can't be described verbally to a blind person. So I don't know how I'm going to do this. I think I'm going to have to do something different as far as how I get this to students. I can still use them, but I can't have anything on my website that a blind person can't have described. So anywho, but we're still okay because that law doesn't come into effect till after this class is over. So that's what. So what I've got here is on my downloads. Let me open it up. Okay. So this is a house I did for my parents. And I'm going to just talk over it rather than look at my PowerPoint. This is a combination of a basement plan, footing and foundation plan, and a first floor framing plan. And so let me go in and zoom in a little bit on it here. So a basement plan is all the stuff that goes into a basement. Now, my parents did not want a finished basement, but they did want a utility sink and rough-ins for a future washer and dryer. And my mom did a lot of canning, so she did want a fruit cellar. And so that's the basement plan part of it. But like some people put bedrooms and bathrooms and all kinds of stuff. So that's the basement stuff. You typically don't show the basement stuff if it's a complicated basement on the footing and foundation plan. Because the footing and foundation plan is just for the foundation walls and the footings for the people that are doing the concrete work. They don't care about the other stuff. So you don't try to show too much. But since my mom and dad really only wanted a rough-in for a washer dryer and a fruit cellar, I showed it on the footing and foundation plan, along with the stairs, obviously. The other thing is that if your framing is really complicated, you might want to have a separate framing plan, floor framing plan. But in this case, it was very straightforward. So I showed the framing. So these little symbols right here are my framing symbols. So that's like a TGI, that's like those wood eye joists. 15 DF was the series back in the day. 11/7/8 is the depth, how deep they are, and 16 inches in center is how they are apart. And the up and down lines mean that those things are spanning from the foundation wall to the beam. It's very easy with Revit or with CAD to copy a bunch of lines and draw lines there, but I was drawing all these lines with pencil by hand, on a drawing board. So I didn't want to draw a lot of lines. And so this would get the job done. And then I showed my drop beams here. I showed my columns. And I did my tributary area exactly the way I showed you how to do it. And then I put the column load there because I said, typical basement column, FHA rated adjustable steel column rated for stated loads. So they could go to the Menards and say, I need a column that's going to take 9.3 or 10.2 kips. Have I talked about what a kip is yet? A kip is 1,000 pounds. Okay. So when you see something on a plan that says 9.3 K on a structural plan, that means 9,300 pounds load was going onto that column. And I did exactly what I showed you. We just did the interior footing sizing. I did exactly what I showed you when I sized these footings. So I sized the worst case one. I sized the one for the 10.2 kips. So I figured out which one had the worst kips, but then I didn't make these footings smaller size, right? I figured out the worst case, which was 30 inches by 30 inches by 12 with number four each way. Everybody knows what number 4 is, right? Those little steel rebars. Top of footing was at an elevation of 91.1. Now, if you zoom in a little bit here, what did I just tell you at last lecture? Presumed soil bearing 2,000 PSF because my mom and dad were too cheap to do a soils report, so I assumed 2,000. So all this stuff I'm teaching you is not just made up for teaching. You can see back, I don't know, 30 years ago, I was putting this on my plans. What you're going to be doing is concentrating on the footing and foundation plan, which is just the concrete. And I'm not going to ask you to do structural sizing or interior footings or beams or anything else. We're just going to do the footing and foundation plan. So when you look at this here, you always are dimensioning. This dotted line is the footing. Remember the part that spreads out on the bottom? The dotted lines that you're seeing on the inside and the outside of the wall are the footings. The solid lines are the foundation wall. So you always dimension your footing and foundation plan to the foundation wall and not to the footing. So that's the one big lesson to take off of this is always dimension to the foundation wall, not the footing. And this works out really good because if you do it the right way, remember I told you last time in the last class that we always dimension to the face of the stud and then the face of the concrete. So, and we line up both of those. So if my face of concrete's at 24 and my foundation, my face of stud on my first floor is 24 feet. Okay, so I don't have this whole thing. Well, how thick is my siding? My siding's lighting up with this. It's just simplifies your life. And that's the way you actually build it in most cases anyway, unless you're doing something weird. So anyway, you always dimension to the outside face of the wall. And then once you've got the wall shown and it's dimensioned properly, you need to know where the top of the wall is and where the bottom of the wall is, or the top of the footing. So you don't do top of wall, bottom wall, you do top of wall and top of footing, because the bottom of the wall equals the top of the footing. Okay. So we've got the footing, we tell them where the top of the footing is. That ends up being the bottom of the wall that they pour on top of it. But then we have to tell them the top of the wall. So let's come up here and look at the garage. I'm going to zoom in a little bit at the garage. So my top of slab and my garage goes from 99 feet 9.5 inch elevation to 99 feet 4-inch elevation. So that's telling me that and I've also tell them here, but my garage is sloping 1/4 inch per foot towards the overhead door. So there's 2 ways of sloping a garage. You can slope it to an interior floor drain in the middle of your garage. How many of you have an interior floor drain in the middle of your garage? Not many, it's very rare, because the problem is they dry out and then the stink comes up into your garage and all this other stuff. So most people's garage slopes to the overhead door. Now, if you ever live in a house where the garage, they didn't slope the garage to the overhead door, which I did at one point up in Wausau, you're gonna find out that all your snow and salt that melts off of your car into your garage ends up running to like some interior wall instead of out the overhead door, and then it sucks up the drywall and all your drywall falls off because it all got wet. So it's very important that you slope that garage to get all the water and snow falling off your car to go out the overhead door. So the long-winded way of saying all that is that the reason that slab is sloping is to get it drained out the door. Now, I don't want to stop the slab where the wall is. I want to have the wall port drop down where the doors are so that slab can go over, because otherwise it would see that joint between the slab and the wall. So let me just sketch that up here. So if I had my wall at the same height as my slab, there's a gap here. We don't want that. So what they typically do is they drop this top of wall wherever there's a door opening. And they pour it like that so that when you're driving out, you don't see the crack where the wall hits the slab. That slab overlaps the wall. Those of you guys in construction, nod your head, because that's the way they do it. I just want to have some other people. So what I'm doing here is I'm showing there that I've got an overhead door and I'm dropping that top of wall. If the top of wall's at 100 normally, and I'm dropping it to 98'8" at the overhead door, what is that drop for the slab? How far am I dropping it? So 100, 4 inches? No. Any other guesses? 1'4", right? So if I took 100 minus 98'8", the 4 inches gets up to 99, and then the 1 foot gets me, so it'd be 1'4", 16 inches down. So just by looking at this drawing, they can tell where the top of the footing is, where the top of the wall is, where I'm dropping it for my overhead door. So you'll see the other thing that's going on here. I have a basement which is down lower than my, there's no basement under my garage. So what happens is, I don't know what, I'll mark it on the board. Let's see if this works. That was a little too much. Okay. I don't know if you can actually see this or not. I got so distracted with that. What was I trying to talk about? Oh, the stepping the slab. Okay, so here's my basement. Way down low. There's my footing, and there's my basement wall, and here's my basement floor. My garage slab is like up here in this neck of the woods. And my garage, how far does my footing need to be below my garage slab or my grade? My grade's about here. Because like I'm driving in at grade, remember my grade's got to be a little bit below all my wood. So I had it 8 inches below all that wood. So my garage floor is going to be here. So this is where grade is, because I don't want to drive up a big hump in to get into my garage. So this is the edge of my garage. So what has to happen is there's no sense me digging out my garage to 8 feet deep because I only have to get 4 feet down for frost, right? So why would I dig this whole garage? So like this is, there's no dirt in here. This is air, but this is dirt. It's just the slab on a grade. So I only have to dig down 4 feet for like a little trench here. So there's no sense for me to dig all this out here. But we need to have our footing continuous and step down. So what's happening is the footing comes out, it steps up, and it steps up until it gets to that 4 foot. So there's probably 2 steps in there. that footing steps. Now, I told you before that, you can keep the bottom at a sloped angle, but what you're really interested in, for the people that are laying out the concrete wall, they need to know where that wall steps up to go from the lower basement level to the higher garage slab level. And that's what's showing here. So if I look at this is my foundation wall, and I've got my top of wall with a little notch for a person door. And then it goes back up, and then I've got another top of wall for the garage door. But then when you see down here, the top of footing, down at the basement, my top of footing's at elevation 91.3. So then it goes up to 93.7. So there's the first step with just this horizontal line here. So let's try my mouse highlighter. I know you guys like that. So let's see if it works. Okay, so what I'm doing by this little horizontal line is if I was looking down at that footing step, that's where I would see the step, right? Because the footing's sticking out on each side of the wall, I would see that step. So there's a horizontal line there and there that's showing that footing is stepping up. And then I'm telling them the top of footing there. So how much did I step that footing up? 93.7, 93 feet 7 inches minus 91 foot 3 inches. What was that footing step then? How high was it stepping up? 93 foot 7 on a higher step, 91.3 on the lower step. How high did it step up? If I took my tape measure, how high was it stepping up? 2 foot 4. So we take 7 minus 3, do we get 4 inches? We take 91 feet minus 91 and we get 2 feet. So it's going up 2 foot 4. Now I've got another step that's 95.11, which is the higher elevation as I'm going around the garage. If I subtract 93 feet 7 inches from 95.11, how much is that step? 2 foot 4 again, right? Because 11 minus 7 is 4, and 95 minus 93 is 4. And you could see now as we come down here, this is their house, and then they had a concrete porch with a slab on grade, which was just like the garage. And so I did the same thing here. That's not going to be dug out under that porch. It's just a slab with, ground underneath it. But I need to keep that footing all consistent. So I stepped it up here to 93.7, just like I did to the garage. And then I stepped it up there to 95.11. Okay, so I think I've looked at this enough. But just based on this drawing alone, they can go in and they've got all the information necessary to pour the foundation, because I'm showing them the width of the footing, I'll show you later on. I'm showing them the thickness of the foundation wall. I'm showing them the top of wall elevation and the bottom or the top of the footing elevation. Okay, so let's move ahead with my PowerPoint here from current slide. So what long-winded way of saying it before is if you can combine them, like what I did, if you can do your basement and your framing and your footing and foundation, fine. If not, if it's too much information, you're going to confuse everybody, draw 3 separate plans, especially like with Revit or AutoCAD. You're not drawing every line from scratch every time you draw another one over. So it's easier to separate them out to make it easier for the people building it to be able to find the information. So just a little reminder, we show the foundation wall with solid lines and we show the footing with dashed lines. And we always dimension to the outside of the foundation wall, not the footing. I'm showing the typical thickness of the foundation wall, or I could also have a note that says typical foundation wall is 9 inches thick. I'm also noting or dimensioning the typical footing information for both interior and perimeter footing. So on this blow up here, I'm just showing you what I showed you before, the interior footings one. And then you also know the typical slab information, including elevation. So I talked about this in more detail. I kind of skipped a little bit. So TOW and TOF stands for top of wall and top of footing. So you should have a little key somewhere that you can't just assume people know what TOW and TOF means. You should have something that spells it out. TOW equals top of wall, TOF equals top of footing. Now, do I need to give them BOF, bottom of footing? No, I don't, because if I tell them that footing's always gonna be a foot thick, all I need to do is give them the top. See, because that top of, here's my footing right here. This top of footing elevation gives me the top of the footing and the bottom of the wall. So it's the most efficient way to tell them how to build this. You just give them the top of the wall and the top of the footing. So you'll see on this plan that I was just showing you, the general notes are all grouped together. This also makes it easier for the contractor because we don't want to have like one note here, one note over here, one note down here. It just put all the notes together, all the notes that you want them to look at that are general notes, put them all together. They can read them all at the same time. Don't make it like Where's Waldo or a treasure hunt where they've got a treasure hunt and find it and read everything. It's like, hey, that's where my notes are. And in reality, if you're doing like multiple plans and all your notes are in the lower left, do it on the first floor plan, the second floor plan, or put them on the lower right, but keep them in a consistent place from plan to plan, because that way, oh yeah, I need to look at that part of the plan to find out what my notes are. Okay, so I'm gonna show you what my general notes together were for my parents' house. Anchor bolts per code. So we're gonna have a code assignment in the next 7 weeks, but the code literally tells you exactly what you need to have for anchor bolts as far as the size and the spacing. Why is that so important that the code micromanages that? Any ideas? Because they don't micromanage like exactly where you put a nail and to nail a stud to a plate, but they micromanage exactly the size of bolts you have and exactly how far you can space them apart. Why do they do that?
For structural support.
Yeah, because believe it or not, all this wood structure, the part you walk on in the walls and the roof, the only thing that holds all that on to the foundation, if there's a tornado or a windstorm or a flood or anything, the only thing holding it on are those anchor bolts. Because when you think about it, if you take those anchor bolts, if they weren't there, you could have a big enough bulldozer, you could just push it right off the foundation of the house. A strong enough wind will just slide it right off the foundation of the house. So when the hurricanes hit Florida, they didn't, obviously a hurricane's a different story, but there were big hotel buildings 3 stories high that the just slid them right off because they didn't have enough foundation anchor bolts to hold them onto their foundation. Okay, so let's keep looking at the notes here. 2 number 4 rebars horizontally at top of wall, grade 8 inches minimum below framing and 4 feet minimum above bottom of footing, right? Because we need our grade below the wood so it doesn't rot out the wood. We need the footing 4 feet minimum below grade. So what I talk about last lecture, frost protection, that's the code. And then the grade needs to slope away from the house so I can get that surface water away from running into my parents' basement. Walls to be adequately braced before backfilling. What that means is when you pour concrete, it doesn't give it its full strength for like a month, basically. So if you've got this concrete, it was just poured yesterday, and you start to backfill it, you get a big, huge construction machine, that wall is it's not at its full strength yet, and you can damage that wall. It will bow it in if you take a big digger and start pouring dirt on a freshly poured concrete wall. Do people ignore this in the real world? Yeah, all the time, because they don't want to wait for it. So they want to go out there and just like, screw it, we're going to backfill as soon as we can because we want to get going on this. But it's really, if you do backfill before the wall, you got to put temporary wood studs at a diagonal in there to stabilize that wall. Walls to have tie-ins removed in parts. So there's little ties that go through the walls from the holds the forms together, and they snap off and they leave little stubs of metal. So what I said was they need to have those tie-ins removed, and then they have to parge them, which is coat them with concrete so you can't see all those. My dad worked in construction. He didn't like to see those little dots from the ties on his walls. Concrete walls 9 inches thick unless noted otherwise. So there's a good general note. Even though I noted it as 9 inches on the plan, that's a good note to have just so that it covers me. Concrete footings extend 4.5 inches each side of wall unless noted otherwise. I could also have said footings to be 18 inches wide by 12 inches thick. And in reality, that would have worked better because, right, 9 inches plus 9 inches is 18 inches. And then I didn't tell them the thickness on that note. I should have just told them that the footings were 12 inches thick. Remember I talked about last lecture that footings need to sit on undisturbed soil, or it's got to be professionally compacted to match what the undisturbed soil is. So I got a note about that. Floor drain and mechanical area. So here I am doing a key top of wall. TOF equals top of footing. TOS equals top of slab. Okay, so all this stuff I'm telling you about, I was doing it before I knew I was going to be a teacher 30 some years ago. So this is a Habitat for Humanity Foundation plan with a basement. And it's drawn on a BIM software, not Revit, it's called SoftPlan. Now in that case, they had very, very thick exterior insulation, which is not typical. So I typically wouldn't even draw the insulation, but in this case, it needed to be drawn just because it was so thick and they did something wacky with the framing. But you still notice, even with that really thick layer of insulation, that's this up and down line stuff, we still are dimensioning it to the face of the concrete and not the insulation. So if you look at this, you could see they probably were looking at this PowerPoint when they did their foundation plan for their habitat house, but they're doing top of wall, top of footing, top of slab, 2000 PSF soil bearing. And I do have a checklist when you get to habitat. But you can see they were copying some of my notes for this habitat house. So now let's look at another one. This one was drawn in Revit. So sometimes, so you'll notice on my parents' house and on this house, the top of wall and top of footing elevations are also often based on first floor being at elevation 100. And the reason it was kind of traditional for a long time to set your first floor at 100 was because your basement and your levels below were negative numbers. You didn't have to deal with positive and negative numbers. So like say we've got 3 levels on a commercial parking garage and they're all 12 foot deep. That would be 36 minus, it would be 64 instead of minus 34. Okay, so you could have a floor level of plus 34 that was like 3 stories up, and you could have a floor level of minus 34 at 3 levels down if you started at 0. But that's too complicated for like just a plus or a minus sign. So they typically would set that first floor at 100 because then your lower levels would never get below 0 because you're never going to have 100 feet below ground. Okay, so that's why it was typically to set the floor elevations at 100 feet. So you can see all concrete footings are 16 inches by 8 inches thick. That's a great note. All concrete walls are 8 inches thick. Anchor bolts per code. So I did the same PowerPoint, when they did this drawing. So they were using this as a check mark. Grade 8 inches minimum, 4 feet minimum bottom footing, grade slopes away from house. Top of wall, top of footing, and preserved soil bearing capacity. Now, what's changed a little bit is Revit defaults to always having your main level be at 0. Like when you look at your elevations of this house you're doing, that main level is always at 0. And that's the way the textbook's set up, and that's the way this Habitat for Humanity plan is set up. Since it's like an extra step that you need to do to get it Revit to be 100 feet at your main level. I don't force students to do 100 feet. So what I do is, so here in this case, you can see that my top of wall is at -1. My top of footing is at -4. So if the same concepts apply, whether you set your first floor at 100 or your top of wall at 100 or your top of wall at 0. I do have a video that shows how you can change your main level elevation from 0 to 100 feet. I'm not going to show it in class. It's kind of more advanced than we need to know it now. It only takes a couple minutes though. So I'm going to go ahead now and show you the assignment. And again, this is too much assignment to get done today for most people. And it's 20 points, so we need to get it right. So I'm going to show you assignment 1.5 foundation plan. I'm going to get a bigger one open here. So show you the second page first. So not only is this going to grade you on, it's not only like to stretch your mind to do a footing and foundation plan. It's to stretch your mind to see something and not just copy it, but have to come up with a plan when I'm not giving you a plan. Like I could give you a foundation plan and say, just copy this and annotate it and dimension it. You wouldn't learn as much. I want you to kind of develop your 3D and visualization and thinking skills. And so the way I decided to teach this was I modeled a little 3D basement in SketchUp. And I gave you an axonometric view, a 3D view from two different directions. And then I gave you the east elevation, west elevation, south elevation, and north elevation. Now in Kim's AutoCAD class, you probably had to do the same thing in AutoCAD world, right? When you did your last project, you had to come up with a floor plan and then you had to show what it was like from east, west, north, and south. So I want you to, based on this sheet here, you have enough information to give me a footing and foundation plan that we can give it to a contractor to build off of. So I'm telling you the foundation walls are 8 inches thick. I'm telling you the footings are 24 inches wide. I'm telling you the footings are 1 foot thick. That's what this 1 foot dimension is. I'm telling you the highest part of the foundation wall is at elevation 100. So that would be up here. I'm telling you how high all the various foundation walls are and where the steps occur. So this is a step footing here. So it goes 4 feet, it steps down, and it goes 4 feet, and then it steps down. And then I've got a stoop on this side here, and that stoop is down a foot. And then my footing is up higher. And that one just is going to be doweled back into the wall there. And I'm not telling you where the slab is, so we can ignore that. I'm just focusing on the footing and the foundation at this point. And then I've got a little notch there, and that little notch shows up in 3D there. And that's the notch, remember I showed you for where the door is? So that's like our sign that there's a door there, and that slab's going to continue out over that. So you have enough information there to draw a floor plan, I'm sorry, a footing and foundation plan to scale that if I gave your assignment that you're going to turn in to a concrete person, they could build it off of that one drawing. They don't need to look at this one I'm giving you to start the assignment. Based on your footing and foundation plan, there's enough notes and dimensions and everything's drawn accurately and to scale that they could build off of that. And so that's why I'm giving you the rest of this class and all next class to work on it, because you haven't done one before. And rather than have you do one and have it be messed up and then, we have to do it over again, I'm going to let you do one. Then we're going to talk about it. You're going to compare notes. And then on the next class. So try to have something done by the next class that we can quality control review it. And then we'll have the final one turned in a starter class a week from today. Now, one thing that students often get confused, and I'm going to give you a little hint since you were nice enough to come into class, is which way, if north is up on the plan, which direction is going to be north? So the way I'm going to test you on this is if north is up on the plan, if I'm drawing a plan view of this little building, which way is the stoop going to be coming out when I'm looking at the floor plan? Is that little stoop, that little rectangle, is that going to be coming up on the top side, the bottom side, the right side, or the left side? Now, the way you can do this is look on the elevations. Which elevation shows the stoop? South. So that means it's coming out onto the south side because it's visible on the south side. So if north is going to be up on the page, which direction should that stoop be sticking out of the plan? Up, down, left, or right? Say something. Down, down, right? Because that's the south side. If north is up, south is down. Okay, so that's just a little hint. Now I've got a little note here. When we're looking down at this, our plan is going to be looking down at this footing and foundation plan. When I have the stepped footing, do I need to show them where this angle happens? No, I don't, because that's based on where the dirt is, right? So if they take the dirt out in steps with like angles, then that bottom is going to follow the dirt. If they do that dirt all one angle, that the bottom of that footing is going to follow the dirt. So the only thing I need to show them on the plan is these little lines on each side show, like there'll be a line on the inside and a line on the outside of that footing that show where the steps occur. And you can see they're shown on this plan here. So this is kind of a deceptively simple. You may be like, yeah, I'm going to get this done in 10 minutes, but it's not going to be 10 minutes. So now let's read the assignment. It is 20 points. So create a footing and foundation plan from the following elevations and 3D views. The foundation plan should be on 11 by 17 landscape, and landscape means the 17 is horizontal and the 11 is vertical. At 1/4 inch per foot and noted and dimensions per the lessons in class. Remember to include a north arrow on your plan sheet. And again, typically on architecture, north arrow is always up. You are encouraged to use, why am I encouraging you to use AutoCAD? Because I don't want you to forget it, right? If I'm going to ask you to use AutoCAD in the next class for a little bit. And I'm going to let you use AutoCAD for this one as well, just because we're using Revit all the time, and I'm scared you're going to forget AutoCAD. Now, you don't have to use AutoCAD. If you hated AutoCAD and you're into Revit now and you want to do this in Revit, we'll do it in Revit. Okay, so it's up to you. However, the purpose of this assignment is to gauge your understanding on how to create a footing and foundation plan, not your software skills. Any software program can be used, or it can be hand drafted using drafting instruments. Freehand sketch drawings will giving a failing grade. If you want to do this assignment in Revit, it would be easier to create as a drafting view as detail lines. So remember when we did the bed and the toilet and the thing, just drawing detail lines? That's the easiest thing to do at this point, rather than trying to model it in 3D in Revit. Okay, so I've had some students that they were way ahead in the book. They're like, I'm going to model it in 3D in Revit, and I'm going to figure out myself how to get this plan to work. And they did it. But if you want to know what's easier, it's easier to just draw it up with lines. And in some ways, I actually prefer that, just because I want you to think, rather than in modeling it in 3D and then have Revit do the drawing for you, I want you to think about what's involved in doing the drawing line by line. So I'm going to suggest if you do it in Revit, it would be easier to do it with the annotation lines, detail lines. So like the one where we did the bookcase and the desk. And I've got a Revit file set up on Blackboard. I've got a Revit file set up on Blackboard with 11 by 17 with a drafting view already set up and on a title block. The reason I did that is I had a lot of people last year that did Revit, but the problem is nobody had showed them how to put title blocks in and all this other stuff. And I got asked like 100 times. So I did a little bit of work if you want to do it in Revit. Now, if you do it in AutoCAD, I figure you know enough from Tim's class on how to set up a sheet and how to get it to print out to scale on 11 by 17. Okay, so you can either do it in Revit or AutoCAD. Let's go back into the assignment one more time here. Believe it or not, I'm also going to let you do it in SketchUp, but you would have to use that layout, remember? SketchUp and layout. So if for some reason you hate Revit and you hate AutoCAD and only thing you remember is SketchUp, you're welcome to do it in SketchUp. You will hand in a 2-scale paper copy for grading. So what we're going to do is you're going to print it out on that printer there, and I'm going to grab my architect scale And if it says 20-foot dimension here, I'm gonna throw a scale on it, and it darn well better be 20 feet dimension in the real world. So not only do we have to draw it to scale, but we have to make sure that it prints out to scale, that you know how to do that. And then you don't have to do a title block. The Revit one has a title block that I loaded in, but the AutoCAD, all I need on the drawing is your name, the date, the assignment name and number, which is right up there, and the class name and number, which is right up there. So somewhere on that plan, put all that stuff in one area. So as I've done this over the years, students tend to miss the same things over and over and over. And this was my list that I used for grading. But I thought, well, why not just show students all the things that everybody ends up getting graded off of, and then maybe they'll use this as quality control check, and I won't have to grade so many red marks on it. So these are your QCR. So I talk a lot about QCR, that stands for quality control review. So I want you to use this as a checklist before turning it in, or if you look at each other's drawings, or if you look at your own drawings. Number one is that it's at the wrong scale. So it's not at a 1/4 inch per foot. The drawing is not to scale. So when you printed it out, you somehow shrunk it, or it's not, like if I throw my scale on it, 20 feet does not scale as 20 feet. The wrong orientation, that means that north is not up on the page. If you're missing a north arrow, there's points off for that. If you've got a north arrow, but your north arrow is not pointing up north, then that's obviously wrong. Missing drawing title and scale, incorrect name. So I do want to have a drawing title and scale. So what that would say would be footing and foundation plan, a line, and then underneath it, it would say 1/4 inch per foot. So let me just draw that on the board here. So all caps, because that's what architects do, is all caps, footing and foundation. So that's the drawing title. And then this is the scale. That's what that's talking about. Now, if you look at the examples I showed you in my PowerPoint, if I can pull those up. That's a drawing title and scale with the north arrow right next to it. That's a good way to do it, because again, the north arrow shouldn't be like, where's Waldo? I'm gonna find an interesting way to hide the north arrow, see if you can find it. Put the drawing title, typically the drawing title's below, I put it the lower left typically. And then I put my north arrow right next to my drawing title. So here it is, foundation plan, a 1/4 inch equals a foot. Let's see if there's a drawing title on this one. Same deal. Foundation plan, a 1/4 inch per foot, north arrow next to it. Let's look at this one here. Title, north arrow, where's Waldo? Okay, so there's an example of what not to use. You have to search over the whole drawing to find it. Now, I'm gonna be embarrassed here. I forgot the north arrow on my parents' plan, so that one I screwed up. Okay, so now let's keep going here. Missing student name, missing student date, missing assignment name and number, missing class name and number. You didn't use all caps. Incorrect perimeter dimensions. All these dimensions got to be, exact and shown. If you miss the dimensions, that's also wrong. Typical wall width noted or dimension, typical footing size noting or dimension. So a lot of times people forget the footing thickness. So if it's 24 inches wide and 1 foot deep, you can't just tell them it's 24 inches wide and not tell them it's 1 foot deep. Correct top of wall and top of footing not noted. No top of footing elevation. Sometimes people just say, screw it, I'm not going to show any top of footing elevations. Sometimes they don't dimension where the footing steps occur. We don't ever want our contractor to be out there with their tape measure trying to scale up our drawing. So if they need to know a dimension, it needs to be dimensioned. No door opening noted. Door opening isn't located. We can't have them with their tape measure trying to figure out where that door opening is supposed to be. It should be dimensioned on there. You get a bonus for doing typical foundation notes like I've talked about. Leaders cross dimension lines. So let's see if I can show you an example of this in a PowerPoint. Okay, so let's show it here. So these are like leaders in the hand drafting world where I'm doing my top of wall and top of footing. You'll notice that I didn't put my leaders out here and run that line across my dimension lines. Okay, so we don't want to confuse people any more than we need to. So like I wouldn't put this top of wall thing up here and then run my leader through the dimension lines. You try to keep those leaders separate from the dimension line. So that's what I'm talking about there. Items too close to left edge. So once you've got this plan laid out on the sheet, you can't have it jammed really close to the edge of the piece of paper because the theory is they might be other floor plans that this is stapled to and it's stapled on the left edge. Arrows don't touch items. So if we are going to point to the footing for the top of the footing, or we're going to point to the wall of the top of the wall, we can't have. So there's our wall, there's our footing. The right way to do it is if I'm going to do top of wall, that arrowhead touches the edge of the wall. It doesn't stop. Here's the wrong way of doing it. Yeah, there's a wall somewhere in that direction, but that's, you have to figure out exactly where I'm pointing to. You actually touch the edge of what you're pointing to. You don't go into the middle of the wall and you don't like stop out here. You exactly touch the wall. Same thing with the footing. If I'm going to do a top of footing, I point exactly at the top of the footing, the edge of the footing. I don't stop a foot away and say, yeah, you'll figure out where that footing eventually is. You actually touch it. No solid line by stoop. A lot of times people, depending on how they draw, they miss all the lines that are needed in that area. Missing inches on elevations. So if we are at 100 and we're dropping down to a certain elevation here, when I put them on the plan, how do we write 100 feet? We write it this way, 100 feet dash 0 inches. We always put the 0 inches. So when we're at an even foot, it doesn't give us the license to drop the foot and inches symbol. Okay, the inches symbol on the dash. So we always have to do feet and inches on the elevation. Same thing with dimensions. If I'm at 20 feet, I don't ever do 20 feet with no inches at the end of it. It's always dash 0 inches if it's an even inch. And then if you misspelled words. Okay. So lots of stuff. I've talked for an hour. We're going to take a break, come back in and get started on it. Try to get something done by Tuesday's class because Tuesday's class is our chance to probably I'm going to pair you up and have you look at, groups of 3, and then you're going to look at each other's and you're going to QCR your own. And then when you've done all that, maybe I'll take a look at it. But we're going to give us some, since it's a 20-point assignment, I don't want to just rush you through it and make it a gotcha assignment. Does that make sense? So we're going to take our time on this because I think it's deceptively simple, but to do it well, we can micromanage like, no, this dimension really is not in the right location. And the only way to do that is to take the time to do it. Okay, so that's all I got for today. I should say for this class. And I'm going to stop recording and stop sharing, and then I'm going to let you get started on it. And obviously you can take a break. Any questions before I stop the recording? Yes.
If you want isometric view like on that.
No, I do not want isometric. I just want a floor plan view, a plan view. So it's called the footing and foundation plan. So all I want is one floor plan, two, footing and foundation plan to scale on a piece of paper that I could give to a contractor and they can build off of. The only reason I'm showing you isometrics, I don't need you to draw these elevations. I don't need you to draw these isometrics. The isometrics are to kind of help you build it in your head and then use that visualization to show you how that the plan should be. Okay. I could have just given you a plan and said, copy this, but you wouldn't have had to go through the procedure of how do I actually draw a plan for this. And this is a fundamental skill. That's why it's 20 points. That's why we're giving you an extra class to work on that. Any other questions? That was an excellent question. See a bunch of chats in here. Let me take a peek at that. Oh, it's just, you were critiquing my moving my camera angle. Okay, that's all I got. Thank you.